So today we're actually going to start on a new lecture, but before that I'm just going to quickly introduce a couple of concepts. So first comment, so homework was posted. I have just posted some videos on petrophysical properties. So if you need a review on what is permeability, what is porosity, what is neutron porosity, well logging, things like those, I have just posted some videos for a review. You don't need, technically, you don't need to know how to define those terms for solving the homework, but it's very easy to know the background, so I hope you remember it from whatever introduction to petroleum engineering you had. I don't think anybody here had petrophysics. So petrophysics is coming up. All of those terms you will learn in a lot more detail. Well logging is coming up too, but it's time to sort of start to think about actual petroleum engineering applications. So again, those videos are just to help you define the terms and learn them a little better. So that's the first note, and I also posted a file which is lecture 3 on programming if you want to download it, but I will use that PowerPoint in the lecture now. Alright, so one quick sort of a review before we move on, which is going to be relevant for solving your homework, and that is on three-dimensional arrays. So far we dealt with matrices, okay, and those matrices were two-dimensional arrays. There is nothing preventing us to continue in 3 dimensions. And actually, the porosity and permeability files that you're going to work with, you're going to visualize porosity and permeability of a reservoir. And that's going to be a 3-dimensional block. So let me just introduce 3D files. They're natural extension of matrices, these 3D arrays. So I'm just going to make it simple for myself. I'm just going to say A is random function. What does rand do? Do we remember? Just generate some random numbers. And I'm going to say 5, 5, 5. So this is going to be 5 by 5 by 5 in 3 dimensions. Okay. So let's generate it quickly. And you can actually see the way it's printed for you on the screen. It's first setting this 3rd dimension to 1, and then I have a 5 by 5 array in the first plane. Then in the 2nd plane, I have another 5 by 5 array, and then in the 3rd plane, another 5 by 5, 5 by 5, and so forth. Okay? Technically, I could do it in more dimensions than 3. It would be just harder to visualize in more dimensions than 3. But it's a natural extension of our 2D grid. Now, of course, it's now a little harder to visualize things as well. Okay? And you will learn and you will be walked through essentially how to visualize those. But just to see, so let's see it again. So again, I have in the first plane, I have 5 by 5. Then another one, altogether 5 of them because that's how many I requested. I could just do surf of one of the, if I do just surf function of one of those slices. Oops. So surface plot, if you remember, will give me just surface of a 2-dimensional, just elevations. So let me just surf plot one of those. Oops, and I might need to restart. Let me try again. Okay. This sometimes happens when I connect to a projector, so excuse me while I restart my MATLAB. It cannot deal with suddenly projecting on the screen, so I have to restart it. And now that I'm restarting it, I realize I didn't start my diary, so I may as well redo everything. Okay, so quick lecture, MATLAB 6 0919. So where was I? A is random of 555. Okay. And I was just doing surface plot of so what does column stand for? All. So basically just give it 5 in the last row and everybody else that's a 5 by 5 other numbers. Okay? So much better. Now if I actually rotate it, so if I activate this little rotation, I can hold the mouse and rotate it, and these are my numbers. So actual 5 values is this, 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 and this. It looks like it's a 4 by 4, right? But there is 5 values in the corners of these. Okay? Cool. Now let's actually just create a little, something a little larger. Or no. So this A is still a 3-dimensional term, and one way to actually visualize all 3 dimensions is to kind of slice in all directions and basically superimpose these slices. And the way you do that is with slice. So you say slice A and have 5 by 5 by 5. Let's do location 3, 3, 3. So what this is going to do, it's going to give me a slice just like this vertical view that I showed of where x is equal to 3, where y is equal to 3, and where z is equal to 3. So let's see how that looks like. So it's roughly in the middle of all of them. So again, and let me set the font size so it's actually visible. So this plane here, I can set the labels X and Y label Y. Okay, so you can see this is X, this is Y. So this plane here is the plane where x is equal to 3. This plane here, this one, is the plane where y is equal to 3. And this plane here is the plane where this one here is where z is equal to 3. Okay? So that's what slice does. You've probably seen these slice views before. Now you know how to actually create them. So you will do this or something similar for your homework with much larger 3D arrays. One thing that there's no actually limit in how many of these planes you can do. You can do something like this. I can say, give me 1, 3 for y, and you're going to get 1 and 3 for y. So you can add as many planes as you want in either of the directions. So you just specify the ones you'd like. So this is giving me, for y, it's giving me both 1 and 3. Yes?
And having A as an argument in there, what exactly is it doing for us?
A is actual data it's plotting. Right? It needs to plot something. So A is this random field that I created to plot.
Okay, so I guess it doesn't really need physical meaning to it.
Right now it's random, so no. But in your homework it's going to be porosity and permeability.
Right, that'll make sense.
That'll make sense, I hope. Okay. If it doesn't make sense, that's because the data is complex. So it's not going to look particularly pretty. Okay, so it's going to be what subsurface is. Okay. Now, in terms of sense, okay, we have created let's see. We have created for surface plot, okay, I have created a z array that depended on x and y, right? And I created values for all of it. I could do the same in 3D. Okay? So I could create now, well, if my values are x, y, and z, I could give myself x, y, and z values and create another vector d, okay, that is a function of x, y, and z. Okay? And I could then slice that one. Does what I make sense? Does it make sense, or am I speaking Croatian? Should I exemplify?
Yeah, I think it would.
Okay. So this is what we did last time in terms of the plot. I said something like this: XY mesh grid. This is what I typed in last, apparently. Okay. And I'm actually going to just make it a smaller array just so it's easier to plot. Okay. And then I created Z like this, correct? Okay. So Z is simply a function. So this mesh grid is giving me pairs of X and Y at every point that I need. And then from those pairs, I'm computing Z at every point. Okay, this is what we did last time. And then I said, okay, surf X, Y, Z is plotting these three. Okay? And this is a crude version just to have smaller arrays so we can easily see it. How would I now actually make that 3D version? Okay? So I would go back to X and Y. Now it's going to be mesh grid X, Y, and Z. So this is simply an array between -2 and 2 with spacing 1. So it's -2, -1, 0, 1, and 2. In all three dimensions it's the same, just to make it simple. So now these are three-dimensional arrays. Okay? X, Y, so you can see that they're three-dimensional. Size of X is 5, 5, 5, size of Y is 5, 5, 5, and Z. They're now triplets of points. Okay, they're not pairs anymore. And now for every triplet, I can compute not Z anymore, but I'm gonna call it D. And I'm gonna just make it D, and it's gonna be X times exponential of minus X squared minus Y squared minus Z squared.
Wait, Professor? How did you get all of those answers? Or did you just type them in?
Size.
Like, what did you do after X, Y, Z equals mesh grid?
Nothing. I was just printing them. X. If I type in X, it's gonna print it.
Okay.
Whatever you have here in the workspace, you can just type its name, it's gonna print it. Okay? So XYZ, this is how I created XYZ. Is everybody with me? Okay. And then I computed D. It's a function of X, Y, and Z. Mathematically, I could keep going. I could have 5 dimensions, just good luck visualizing. Okay, so this is my D. Now my D is a 3-dimensional array. So to view it, I can't do surf, or I can just surf of one of those planes. So I can actually do slice. Slice of D, and I'm going to also do a 3, 3, 3. Okay, so this is how this D looked like. I could repeat it with a little better resolution, so it's a larger. So if I just say here 0.1 maybe, or 0.2. 0.2, and 0.2. So my size of x is a little larger. It's 21 by 21 by 21. And then I'm going to recompute d. So my d will be 21 by 21. So if I do slice, maybe I can do slice at 10, 10, 10, halfway. Okay? So this is this function now. And again, you can rotate. Okay? So you can see sort of a projection. It's symmetric x, y, z. There's only a difference with that x. Relatively symmetric, not completely. Okay, does this make sense? So I'm just generalizing what we did. So does this data make a little more sense than randomized? Okay.
So the function itself is actually the colors changing.
Right.
Okay.
Right. And you can do that. You can say, okay, color bar. So you can add a color bar that will tell you what is corresponding to each color. And of course, I need actually to set these font sizes a little larger so it's readable. Here we go. So my blues are my cold and they're minus 0.4, and my yellows are warm and they're 0.4.
How did you do the GCA?
Set GCA font size 16 will create, GCA is the current axis, so-called handle. So grab the current axis and modify font size to 16. Okay. How do I add a title to this beautiful file? Title. So command title. We'll add a title. And I'm going to say 3D array example. Yes. So this should help you with the homework. It's just that the files will be larger and they will be actually meaningful in petroleum engineering. There will be porosity and permeability. This is just a function for math. All right. With those examples out of the way, let's actually continue or start a new lecture, lecture 3. Since we are starting a new lecture, hint, hint, sometime in near future there will be a quiz on lecture 2. Just saying. So lecture 3, and we will deal with it this week and probably start on the next, about 3 to 4 lectures, is actually going to be dealing with programming elements that will allow us to build a better and more functional code that can be executed multiple times and also in future. So not for just one homework that we are solving, but probably we can reuse some of that code for later on. So in order to do that, we actually have to, instead of just keep typing these files, I have to actually remember pieces of code, and we will learn scripts and functions in order to do that. So there are actually specific sets of commands that can be executed again. And then also I will learn how to build a smarter code. So there are 2 essential parts to every programming. A, telling the computer to repeat something 1,000 times, million times, however many times I need it, because humans are not capable of doing that. Not quickly enough anyway. Maybe in geologic time, but we don't live that long. Okay. So essentially, I need to be able to tell computer how to complete something multiple times, and I also have to be able to tell it when to complete something. So given that something is true, please do this, and if something else is true, please do something else. So some sort of like roadmaps on how to proceed. Okay? And of course, I want to say, okay, in petroleum engineering, if your pressure is way higher than it should be, you want to do something, right? So you should be able to build some construct that will actually stop, send an alert, wake up of the Velvor and so forth, because there's a kick. Okay? So in essence, I need to be able to build these roadmaps. And we will essentially, in every programming language, in order to do that, you need relational operators. That's basically saying if so-and-so is less than, that's your relational operator, a number that is your threshold, do this. Okay? So all kinds of operators that do that are called relational operators, and you know them very well. We will just now formalize them in programming. And if else, we'll just tell you, well, if something is true, do this. So that's two things that will tell you how to build roadmaps. And the loops we will tell computer how to repeat something multiple times, and we will have a number of different groups. And then there's comments on something that is very specific and very effective in MATLAB, which is vectorization and global variables. So after we have that, we will make comments on what are the errors that we're making whenever we're computing something. And we will be ready to go to actually go and build algorithms ourselves. So we are still working on our toolbox. So without further ado, let's get going. So first thing that we need to do is we will introduce script files and function files. Script files I actually introduced last time already. So anything that you type into command line, you can get those commands, put them in a file. You will call that file .n, so MATLAB will know that it's a script file in MATLAB, and you can execute it again by typing in the name of that file. That's a script file. Now, if you want to be smarter and say, okay, today I want that size of that random matrix to be 5, but tomorrow I might want that size to be 20. Day after that I might be greedy and I want 200. Okay? So I want to change some sort of input variable, but the main logical structure of what I want to do is the same. Okay? Then I need a function. Function will actually take some input parameter for me that I want to change, and based on that input parameter, it will still execute everything the same, and possibly also return something and give that back to me. Okay? So that's sort of a more general way that I can reuse better later on. So those are essentially functions. So I will need inputs and I will need outputs. And script is essentially a function without input. Okay, so it's just a bunch of commands. And then we will also focus on certain, if you want to give human back certain data, you have to print it in a human readable format. So we will also figure out how to interact with a human. How do I take an input from a human? And how do I display it in some way that human can read? Because just because I crunch some numbers and I have them in memory, that doesn't mean that the above mentioned human can actually know what's going on. Okay? So this is basically interfacing with a human operator. And if you would like to read on your own, in our textbook, Applied Numerical Methods with MATLAB, you can focus on chapter 3. So, one thing that we haven't introduced yet in our scripts is, okay, you can just put a bunch of commands together, but you can also add some comments because you might not remember how you did and what you did and why. So let me actually give this an example. So I might actually want to remember this example here. So I'm going to copy it. Okay. And I'm going to say either new script or new script. On your computer, it might be in slightly different position. Okay. So now I have a script that is untitled. And I'm going to do Control-V or copy into this. And I'm just going to get rid of things that I don't need. So this is basically the code that I just had before. So first, this is a script that I would like to execute later. So I'm going to save it under name. Save as, and this is slice example 3D array. So I'm basically providing an example to slice a 3D array. So if you do that, I can now just execute it. And I'm going to close this previous figure so I can prove it to you that it's executing again. Here it is. Great. I know today very well what am I doing. A week from now I might forget, and I'm not going to even mention what's happening 3 months from now or 3 years from now. So maybe it is a good idea to say, okay, this is create X, Y, Z pairs of or not pairs, triplets of points using mesh grid. Compute a function d of x, y, z. So for every triplet, compute this function d. Slice is a visualization. I might or might not need. Visualize cross sections of d where x is equal to 10, y is equal to 10, and z is equal to 10. And by 10 I mean 10th element. Okay. So maybe I should use I, J, K. Does that make sense? So it's not an absolute value 10, it's where I have a 10th element in this. This D is 21 by 21 by 21, and I'm looking at 10 elements. So basically cross sections, maybe it's clearest if I cross sections of D of 10, everything, everything, D of everything, 10, everything, and D of okay. So if I change this to, for instance, 4, 10, and 14, then this would be 4, 10, and 14. Does this make sense? See what is corresponding to what. Okay. So this 4 means that I'm actually executing where this element is 4 and everything else is a slice. And this is make the plot pretty. So my point is that whatever I type in after %sign is just a comment for the human reading the code. Okay? So if I can also execute this script from here. So it's going to re-execute, and it's now changing positions slightly. So you can see it at 4, 10, and 14. Okay? Yes? So that's a script. So it's just a sequence of commands. Another thing about the script is, I'm gonna do clear all, and that way I erase everything that is in the memory. Okay. With close all, you will also close all of the figures. Sometimes it's good to clean up. I once opened 200 figures at the same time. It froze my computer. So if you open too many, close all is helpful. Or you have to kill MATLAB altogether. So now if I execute this slice example 3D array again, it's going to create all of the variables x, y, z, and d in my workspace. So it's talking directly to the workspace. Does that make sense? And it's also whatever I have in my workspace already defined, you can use it. Okay. Now, my whole point is that, okay, tomorrow I might feel differently about what to use here as an input. So possibly, oh, is this 0.2? Or is it 1? Or is it 0.1? Or how fine do I want this plot to look like? That might be a possible input. Okay. So I'm now going to save this differently, and I'm going to show you how to make this actually an input. So first step, the way I would do it, when I'm just testing, is I would just say, okay, this 0.2 is something that I might want to frequently change. So I'm just going to say dx as 0.2. So I'm just going to use this dx, dy, dx. I'm still going to use dx in all cases. Okay. So this just makes it easier for me to change it. I'm changing it in one spot instead of three. So that's sort of step one in parameterizing your function. So then if I want to change it, well, okay, let's go with 0.1. So if I re-execute, you're going to see that these are now larger files, 41 by 41 by 41, and I can see many more dark lines for all of the little boxes. Okay. Now if I actually want to make it a function, I'm going to say save as. And I'm going to add func at the end. And I'm now going to make this dx an input. So I'm going to say name of the function is slice example 3D array func of dx. And I need to tell MATLAB this is now a function, otherwise it really doesn't know. So I'm going to say function and I'm going to give myself a comment. So dx is spacing for x, y, z arrays. So give yourself a note. What's that dx business? There.
So you went to the very top.
Mm-hmm. So this is again comment. This is just for us humans. MATLAB ignores it. Couldn't care less what you wrote there.
And then that would be the name of the file, right?
Yeah. And then save this. So I'm now going to try to execute this for a slightly different dx. So I change my mind. The way I will execute this, I will give it a name, which is the script name is the same as the function name. Okay? And I'm going to provide it with input. So I'm going to go back to that 1 spacing and execute it for that. Whoops. You know what happened here? 4, 10, and 14. 10 and 14 don't make sense for this discretization. I don't have 10, I don't have 14. It's empty stuff. I'm going to fix this. The process of fixing this code is called debugging. That's our lecture 4, by the way. Okay. So these 4, 10, and 14 don't necessarily make sense. So I'm going to actually say 0.3 or, yeah, 3. Why not? That makes a little more sense. Okay. That's the spacing, how many points. So I'm creating x between -2 and 2, and I'm giving it spacing. So the smaller it is, the more points I have. And so if I put spacing as 1, I have really 5 points in each direction. So 10 and 14 don't make sense because I don't have those. So obviously these should be input parameters too. Okay, where do you want to plot this? Okay.
So how does it know where to plug in the input parameters in the function?
I gave it right here. So this is why it knows that it requires 1 input parameter and it's called dx. So that whatever I specify is going to treat as dx within this function. Now there's one thing. The size of this array has obviously changed. Has xyz here changed? This 41 by 41 by 41 is my old input when I had 0.1 is dx. Key thing about function is what goes into function stays in function. Remember Las Vegas? So function takes stuff, does what it needs to do, and it deletes everything from the workspace. So whatever changes you made to this internal stuff, it's not going to show in your workspace. Function cleans up after itself. Unless you send something out as an output. So you are controlling what goes in, and there's a control of what comes out. And since we didn't provide anything, we didn't specify anything as output. There was no output, so basically if I just did clear all and executed this again, nothing will show up in my workspace. It created XYZD, it plotted it, and then it went out and cleaned up after itself. So functions are also good for cleaning things up, especially if you don't need things in your workspace. So 2 major differences is that function takes input. We are going to now work on how to provide output, but essentially function also cleans up after itself, so unless you specifically grab something and remember it, it's not going to give it back to you into the workspace. And that's, for the most part, a good thing. Because otherwise you might have a whole lot of trash sitting in your... Are we clear with these main?
Wait, how did you, could you, like, take away the graph?
Make the graph go away. I will.
Oh, so there's nothing.
So both scripts and functions are also scripts. So I'm going to call or execute by their name. Okay. Function also has inputs, so I can specify input. And it could have an output. So let's say that one of these arrays, let's say that I want D as an output. And then I'm gonna give myself a note, function returns d of x, y, z, 3D array. So now if I want to grab that d from the function, then I will say d equals and if I do that and execute again, you will see that d gets created now in the workspace. So d is output variable. So whatever it is that you had here computed, you can return it back. D I created right here. Yes?
So the actual plot is B with an output and
No. Plot is plot. You can save it if you want, but it's not saved as an output. I could have a save function within here that would actually save a plot. So you can automate that. But for the most part, here's the data doing it whatever. Yeah. Alright. So let's now go through the files, and there will be now more examples in this discussion. So essentially, I already introduced how you open a file. So there's one of these common open routines. This is how it looks like on a Windows machine, and an older one on my machine you saw it looked a little different. And this is something that changes from version of MATLAB to version of MATLAB. So anything that you would like to be written in, you can. Here's another example. Yes?
I tried to be lecture 5. This one.
Is this the name of your function? Did you save your file? Does it have D as an output? Function D equals to
Function D.
this is essential for saving.
Oh.
Yes. So unless you put it this way, it's not going to be an output. Now this way I defined an output D. Okay. So this is another example script. So whatever it is that I would like to put in, it could be just executed as a sequence of commands. And anything that you would like as a comment, you can put after %sign. Now function formally has a function name. Okay? It should be the same as name of the file. Otherwise, MATLAB will actually underline it in orange for you, and it will make noise about it. Okay? You could have more than one parameter. So I exemplified dx. It could be dx, dy, dz, whatever it is that I feel like having as input parameter, I could. And also, it could have more than one output parameter. If I have more than one, then I actually have to use these brackets, and they have to be spaced out by the comma. So d, comma x, comma y, comma z, and so forth. Okay. So they're all separated by commas, and inputs are separated by commas as well. Input list has these curved brackets, and output list has these angular brackets. So basically, I give input parameters to a function file, it works on stuff, and it gives me back output parameters only if I want to. Okay? So it's important to have this first function name. This part is important so that MATLAB actually knows you're defining a function. Okay. And it should be the same. The actual functional name has to be the same as the name of the file, except that name of the file will have .m. Okay? So .m is not part of the function name. It's just telling the operating system these are MATLAB files. Okay? And output list is optional. It has the square brackets and any kind of variables we worked with, vectors, scalars, matrices, strings, anything can actually be input and output of a function. Okay. So here is an example. If I had a function that will simply add and multiply two numbers, and I'm calling it add_mult, okay? Its input parameter list is x, y, and output is sum and product, so s, p. I have to have square brackets around these, and then all function does is adds and multiplies these two. How do I call my outputs and inputs in workspace? It doesn't really matter. Okay. Whatever function gets as these two numbers, it's going to interpret within the function as x and y and work with it, and then gives it an output. Okay. The names that I use in the workspace versus the names that I use in the function can be two separate things because what's in the function, it stays in the function. Okay. So naming game is important to me in the workspace, and it's important to me separately while I'm creating the function, but then I don't need to know what those names are within the function to operate with the function. So let's actually create this simple example so we can start working with it next time. So I'm just going to say new or new function. Okay? And MATLAB is kind enough to already give you suggestion how a function should look like. So we can just say s, p is add_mult of x, y.
You have to add a comma.
If you have two of them, yes, you have to have comma. It is a good idea to have summary of the function. Add and multiply two numbers x, y. And I actually like copying this entire first line and putting it as part of the comment. That way I know what output and input parameters are. And my sum is x plus y, and my product is x times y. And just save it before we stop. And I'm going to save it as add_mult.m. So again, the name of the function and the name of the file should be the same. And when you save it, you will see it shows up in your current directory. Okay? So this is what we will be working with next time.